We're going to start our next video lesson on the quotient rule. So we were doing the product rule earlier. We've already done the power rule, and we've done two basic trig derivatives, sine of x and cosine of x. So keep in mind, as we keep adding to the rules, it would be helpful if you kept a list of these rules somewhere on a sheet of paper or on note cards, because you're going to need to reference them often, and they do need to be memorized. Okay, just like you're adding, subtracting, multiplication, division tables when you were doing in elementary school. These are the elementary functions of calculus. So therefore, you need to know all these rules. So it's nice to have a quick reference to look at. The more you look at them, the more you use them, the easier they are to remember. Okay, so let's talk about what the quotient rule is and when we use it. So our quotient rule is when two functions of x are being divided. So again, we're going to use the u and v notation. So we're going to let u and v be functions of x. You could also call them f of x and g of x. This is just a little bit easier. Then the derivative with respect to x of u divided by v, so these are your two functions of x being divided, is this. And this one's a little difficult to remember, so we're going to have this little phrase to help us. So v, which is the bottom function, du, the derivative of the top function, minus, this is important because this is not a commutative rule like product rule is. All right, u and v, all right, cannot be interchanged. All right, so minus u, which is the top function, times dv, the derivative of the bottom function. And then we just put the bottom function squared. Okay, so this can be a little trickier rule than just product rule, which is u dv plus v du. All right. Here we have the minus, so the order matters. So this is the phrase that we're going to use to help remember it. And if we were in class, we would say this phrase out loud numerous times. So I would like you to try to do that to help remember it. The more you say it out loud, the easier it is to remember. And every single time we use quotient rule, I'm going to say it. So it's low d high, right? Low being the v function, high being the u function. So low d high minus high d low over the square of what's below. So the reason why we have this phrase is because it rhymes. So it helps you remember that it's low d high minus high d low, not the reverse, or else it wouldn't rhyme. All right, so low d high minus high d low over the square of what's below. Low d high minus high d low over the square of what's below. You should be saying it out loud with me right now as we go through. Let's do it again. Low d high minus high d low over the square of what's below. All right, just like when you learn quadratic formula, you had little ways of remembering that. This is the one that we're going to use for quotient rule. Say it as many times as you need. It's not going to change. What you can't do, and what some people try to do, is say, well, I'm just going to take the derivative of the top and the bottom and divide them. That's not going to work. Just like product rule, if you have two functions being multiplied, you can't just multiply their derivatives. The only rule for that is when you have addition and subtraction of two functions, you can just add and subtract their derivatives. Okay, so let's look at some examples. So here, it says find the derivative of y equals 5x minus 2 over x squared plus 1. So here we have a rational function. And if we could, this is what I'm going to ask myself before every single problem, can this function be rewritten or simplified in a way that it could be the sum and difference of powers or even the sum and difference of trig functions? And it's not. Okay, we could write it as a product with a negative exponent, but that's making it harder. All right. So because the bottom is two terms, not a single term, if we had a single term on the bottom, we're allowed to split up the numerator, but we don't have that here. So this is a problem that we have a quotient. We have to use quotient rule. So our quotient rule is low d high minus high d low over the square of what's below. So I like to write it out with parentheses, just like with product rule when we do that one out. So again, I'm keeping this labeled. Some of you guys in the homework assignments, you're not labeling your functions, and you need to do that, because there's a distinction between which function's y, which one's dy dx, which one could be the second derivative, which would be d squared y dx squared, or y double prime. So make sure you keep them labeled as you're going through the homeworks, because sometimes some of your work, I'm just seeing a bunch of expressions written down and I don't know what's what. Okay, so make sure you keep them labeled. Okay, so here's our derivative. Low d high minus high d low. D low, you had to use a power rule, over the square of what's below. There's no derivatives on the bottom. You're just squaring whatever was on the bottom. All right. So this is technically our derivative. So we're technically done, but we're going to simplify it because eventually we're going to use derivatives to evaluate and to set them equal and solve. So we're going to want to simplify them if we can. So let's distribute the 5. And we also have to distribute the 2x and the negative here. All right, so this is why parentheses are so important. When the parentheses aren't there, you're writing expressions that are not the same as this. So make sure you put the correct parentheses. So when we distribute the 5, we get 5x squared plus 5. We distribute the negative 2x, we get minus 10x squared plus 4x. Okay. The bottom, we're just going to keep it as x squared plus 1 squared. And then we're just going to combine like terms on top. 5x squared minus 10x squared is negative 5x squared. So I just put that at the end. We don't like to write negatives out in front because the equal sign can get confusing. And this would be it. This is as simplified as the derivative can get. The top's not factorable. If we could factor it, we could, but we just want to get it into combined like terms. All right. So again, you cannot just say the derivative of this is 5 over 2x. That doesn't work. All right. You can't just take the top and bottom and divide it. This is the correct derivative. All right. So don't make up your own rules. You have to use the rules that are provided for you. All right. And remember, this represents the slope of this function at any value of x. All right. And where this function doesn't exist, which is technically nowhere because the domain is all reals, the domain here would be the same thing, all reals. Okay, so let's take a look at another function. So here is a trig function that we do not know the derivative for. But now that we have the quotient rule, we could use it. So another way to write tan of x using our trig identities is sine x over cosine x. Right? That's one of our identities that we did this year. We definitely use identities sometimes to simplify or rewrite functions to make them easier. But now we can use it to take the derivative using quotient rule. So now that we have a quotient and we know the derivatives of sine of x and cosine of x, we're going to use our quotient rule. So now, again, notice how I'm labeling it. This was f of x because this was still the original function, but now this is the derivative. So I'm labeling this f prime of x. And now we've got our quotient rule. Low, d high, derivative of the high function, derivative of sine x is cosine of x, minus high, d low, derivative of cosine x is negative sine x, over the square of what's below. Okay, so now we can simplify by getting rid of parentheses. The shorthand way to write cosine x times cosine x is cosine squared x. Here, the negative times the negative will become positive, and we'll get sine squared x. And on the bottom, when you have the parentheses here, that means you have cosine squared. It's important to put these parentheses here if you're going to put the squared after the cosine of x. All right, it has to be in parentheses. Okay, so now this is our derivative, but this can even simplify more because we've got a Pythagorean identity here. All right, so this top simplifies to be 1. That's one of our Pythagorean identities. And 1 over cosine squared x, we could write that as a single trig function, is secant squared x. So this is going to become the rule for the derivative of tan of x. And again, rules are ones we just need to memorize. So I'm going to give you all the trig rules now that we just proved this one. You could prove cotan x in a similar way. Same thing with secant and cosecant. We're just not going to go through the process of each one. We're just going to know that we need to memorize them. So here are your 6 trig derivatives. So again, you can pause this and copy them down into your notebook or onto your rules sheet, which you should. Okay, we've done the first 2 already. Derivative of sine of x is cosine of x. Derivative of cosine x is negative sine x. We just did this one. The derivative of tan x is secant squared x. And you could similarly do the derivative of cotan x is negative cosecant squared x. And then the 2 for secant and cosecant are a little trickier to prove, but again, they're just rules we need to know. So the derivative of secant x is secant of x times tan of x. Derivative of cosecant of x is negative cosecant x cotangent x. Yes, you need to memorize all 6 of these, but the more you use them, the easier they become. Right? But again, have that reference sheet with all your derivative rules, right? And that will be very helpful as we go through it. And remember, the variables can change. This could be d theta of sine of theta is cosine theta. All right, so it's whatever variable you're using, you would just be consistent with. And another thing to remember, a trick to remember which ones are negative, if you're taking the derivative of a trig function that begins with c, cosine, cosecant, or cotangent, then the derivative will be negative. All right. The derivative, if it doesn't begin with a c, those were positive derivatives. Okay, so that's just a little trick to remember which ones are negative. Cosine, cosecant, cotangent have negative derivatives. Okay, so let's do a couple more examples. So here we want to find the derivative of y equals 1 minus cosine x over sine x. So we've got our trig functions here, and this is written as a quotient. So if we want, we could do our quotient rule. Low d high minus high d low over the square of what's below. But since there's only a single term on the denominator, we're allowed to split up the numerator and divide both of them by sine of x. And by doing that, we could write this as the sum and difference of trigs, which would be an easier rule than quotient rule. Quotient rule wouldn't be incorrect. You could still do that, but sometimes it's better to simplify the original function first to take the derivative using an easier technique. So let's show that. So again, I'm still calling it y because I haven't taken the derivative yet. I'm just using my algebraic techniques, which we talked about a couple days ago. I'm dividing both of these by sine of x. All right, so we've got 1 over sine x minus cosine over sine, which 1 over sine is cosecant x. Cosine over sine is cotan of x. And now since we've got the difference of two trigs, we can just take the difference of their derivatives. So now we're taking the derivative, so we're going to call it dy dx equals derivative for cosecant x is negative cosecant x times cotangent x. Derivative of cotangent x is negative cosecant squared, so we get plus cosecant squared. And then if you want to, you could factor. You could take out a cosecant x from each term. When you take it out here, you're left with cosecant. When you take it out here, you're left with minus cotangent, so I just put the minus term second. Either one of these is fine, though. One is not more correct than the other, but sometimes it will be useful to factor the derivative. All right, so let's take a look at our last example, and then you can get the assignment. Okay, so this one says to find the second derivative of y equals ln of x over 2x. So again, looking at this function, this is a quotient. So we'd have to use quotient rule unless we could simplify it, but there's no way to rewrite this so that it's not a quotient. You could write it as times x to the negative 1 up top, but then that's a product rule with a negative exponent. That's not going to be easier. The only time you want to do it is if you can rewrite it as the sum and difference of powers or the sum and difference of trig functions, right? Taking a quotient and rewriting it as a product rule is not going to be easier. Okay, so these functions are both pretty simple. We're just going to do our low d high minus high d low over the square of what's below. So again, I'm calling this y prime because it's the derivative equals, and each one is in parentheses. So low d high, derivative ln of x is 1 over x, minus high d low over the square of what's below. So you need those parentheses around the 2x because you have to square both of them. Okay, so let's simplify this before we find the second derivative. So when we multiply the first two terms together, the x's cancel and we're left with just 2. And then here, the 2 has to get multiplied out in front because, again, this x is inside the log. It's untouchable, just like with trigs. And then on the bottom, we're squaring both terms because it's a product, and we get 4x squared. So 2 minus 2 ln x over 4x squared, that's as simple as this can get. So now to find our second derivative, this is a quotient. Now there's a single term on the bottom, so you could technically split it up. But if you did that, 2 ln x over 4x squared, that would still be a quotient, and you have to use quotient rule anyway. So this one, it's just better to keep it like this and do your quotient rule. So we have so now we're going to call it y double prime because now we're taking the derivative. This is why labels are so important. Don't just have a bunch of expressions written everywhere without labels. Right? So our second derivative, y double prime, equals low d high. So the derivative of 2 is 0. Derivative of minus 2 ln x, this is just a coefficient. So we just get negative 2 over x. Minus high d low. So the high function stays as it is. D low, that's a power rule. You get 8x over the square of what's below. So we're going to simplify this out a little bit. Multiply the first two terms together, you get negative 8x. And then here we have to distribute the negative and the 8x to both terms inside, and then we have to square the bottom. So we should get negative 8x for our first term, minus 16x, plus, because the negative times the negative, plus 16x ln x. So we're not allowed to reduce just one term. If we want to reduce, we have to reduce all three. But here we actually can combine these two first to get negative 24x. And then all negative 24, 16, and 16 can all reduce by 8. So basically, you can factor an 8 from the numerator and cancel it out. And this should be your final simplified derivative. Since we had a minus here, I just moved it behind. So when you combine these to get negative 24, and then we reduce everything by 8, Negative 24x divided by 8 is negative 3x. Here, this divided by 8 is 2x ln x, and then this divided by 8 would be just 2x to the fourth. So this would be your simplified second derivative, and you had to use quotient rule on both. So for your homework assignment, the worksheet that's posted, it says use any of the rules necessary. So some functions you might be able to rewrite and just use power rule, or rewrite and just use your trig rules, or maybe use a product rule, or you might have to use quotient rule. All right, so now that we have all 4 of those, you have to figure out which one to do for each problem. This is not one where every single problem is going to be a quotient rule. Okay. Also remember, we now have our 6 trig functions, so any of those six trig functions could show up on any problems that we do so far. Okay, so remember, every Tuesday and Thursday, I have live office hours from 1 to 2. If you have any questions on this or previous assignments, if you've checked answer keys and aren't sure about anything, let me know. All right, guys. So this will be due on Monday.